When it comes to speed, there are actually two slightly different words that we use. Speed is a scalar and velocity is a vector. Speed is the distance travelled divided by the time taken. So you can see because it's based on distance, it's going to be a scalar. Velocity is the time rate of change of displacement. And again, because it's based on displacement, which is a vector, that means velocity is also going to be a vector. Now, velocity is a v, or sometimes later on we'll use a u as well for initial velocity and a v for final velocity. There is unfortunately no commonly accepted letter for speed. It's just the way it is. We can't use s because s is displacement. So, speed is distance divided by time, and velocity is change of displacement divided by time. Now, although I've said it's usually meters per second, depending on context, kilometres per hour or kilometres per minute or who knows what else might be just as useful. If you do have to convert between metres per second and kilometres per hour, you have to multiply or divide by 3.6. Now, where did 3.6 come from? Well, if you think about it, there are 60 seconds in a minute and 60 minutes in an hour, and there are 1,000 metres in a kilometre. So if you want to convert from kilometres an hour to metres per second, you're going to be dividing by 3.6. To convert from metres per second to kilometres per hour, multiply by 3.6. Now I'm going to show you a few examples. The first is really about average speed as opposed to instantaneous speed. Annabelle drives 120 kilometres over a 1 hour period, stops for lunch for an hour and a half, and then covers the next 200 kilometres in 2 hours. Calculate her average speed. So, the 120 and the 200, well, this is 120 in 1 hour, so 120 kilometres an hour, and this is the 200 kilometres in 2 hours, so that's 100 kilometres an hour. That's instantaneous speed. Well, it might be an average, but I'm going to assume it's instantaneous. But her average speed for the whole trip is different. Find a good colour. Her average speed for the whole trip is the total distance that she's travelled divided by the total time taken. So Annabelle travelled 120 plus 200, or 320 kilometres. And it took her 1 hour plus 1.5 hours plus 2 hours. 1 plus 1.5 plus 2, which is, that was hours, which is 320 divided by 4.5 hours. I'll put the units in because it'll give us a hint as to what the final units will be. My speed is going to be kilometres per hour. And it's 320 divided by 4.5, except I can't type it right, 4.5. Still doing bad, I'll use the keyboard instead, which is 71.1 kilometres per hour. 71.1 kilometres per hour. The second example is to show you speed and velocity. Jonathan drives 500 kilometres north in 6 hours. Calculate his average speed and velocity. Now, the only difference here between speed and velocity is that velocity is going to have a direction because it's a vector. So the speed is the distance travelled divided by the time it took, which is 500 divided by 6 hours. 83 1/3 kilometres per hour. 83, well, I may as well write the third, kilometres per hour. The velocity has the same value, 83 1/3 kilometres an hour, but it also has a direction, north, and that's the difference between the speed and the velocity. But of course, because the velocity is a vector, it's going to make a big difference if there's other directions involved. So let me show you a more complex example. Michael drives his Nissan Pulsar 4 kilometres north and then 6 kilometres west in 10 minutes. Calculate his average speed and velocity. So let's have a go at speed. Speed is easier. It's a scalar. Total distance travelled divided by total time taken. So the distance was 4 kilometres north and 6 kilometres west for a total of 10 kilometres in 10 minutes. Whoops, 10 minutes, which if you like is 1 kilometre per minute. Now, min is actually not a standard accepted abbreviation for minute. I'm going to use it anyway. To make this make more sense, if you're going 1 kilometre per minute, how many kilometres will you go in an hour? You must be going 60. 60 kilometres per hour. But velocity is more complex because it's a vector. He's going 4 kilometres north and then 6 kilometres west. We actually want to find the velocity here as a vector. But to get the velocity, this is actually a displacement and a distance and a distance. I actually want to find the displacement first. Notice S is displacement, not speed. That's what I warned you about. So the length of that displacement vector is 6 squared plus 4 squared, which is, let me get my calculator, square root of 6 squared plus 4 squared. Whoa, what happened there? 4 squared, which is 7.211. 7.211 kilometres. So the magnitude of the velocity is that distance, that's the length of that displacement vector, divided by the time taken, 10 minutes, which is, I don't need a calculator for that, 0.7211 kilometres per minute. And again, I probably want kilometres per hour, so times this by 60. If it goes that far per minute, I have 60 of those in an hour. Times that by 60, whoops, no, divided by 10, and then times it by 60, 43.3 kilometres per hour. Bit of a mess. So that's how fast the velocity, the average velocity is. Notice the difference because we're now talking about a vector. But because it's a vector, I actually need to give the direction here. Let me get my red back. I actually have to give this direction of that velocity. So that angle is inverse tan of 6/4. Let's try it. Am I in degrees? I am in degrees, yes. Inverse tan of 6 on 4. 56.3 degrees. 56.3 degrees. So my velocity then is this 43.3 kilometres per hour, and the direction is north 56.3 west. North 56.3 degrees west. Now you could give this as a proper bearing if you wanted. Angle clockwise from north, you'd subtract that from 360. But this is a perfectly good answer in this context. Actually, all the numbers in the question have two significant figures. This one's technically only one. I could probably just say 43 and 56. That's good enough.